ESA's pioneering wind mission, Aeolus, is coming home. Currently falling at 1 kilometer a day, its descent is accelerating. Soon, ESA's spacecraft operators will attempt to guide Aeolus's descent home in a first-of-its-kind assisted reentry. But first, let's take a step back. Aeolus launched into orbit in August 2018 from Europe's spaceport in French Guiana and became the first satellite to measure global winds from space using a laser. Named after Aeolus, the keeper of the winds in Greek mythology, the satellite carries one of the most sophisticated instruments ever to be put into orbit. The Aladdin instrument beamed down 7 billion pulses of UV light to profile Earth's wind. Although designed as a 3-year mission, Aeolus has exceeded not only its predicted lifetime, but also all expectations. Over the past 5 years, its data has been used in major weather forecasting services worldwide. It has tracked the Hunga Tonga volcanic plume, improved the forecasting of hurricanes, followed the huge Saharan dust plume, shed a light on Earth's polar vortex, and filled the gap in weather forecasts when airplanes were grounded during COVID lockdowns. Altogether, it has brought 3.5 billion euros worth of economic benefits over its lifetime, and is hailed as one of the most successful missions ever built and flown by ESA. But now it's time for Aeolus to come home. Gravity and the grasping wisps of Earth's atmosphere, sped up by solar activity, are dragging Aeolus down from its altitude of 320 kilometers. Aeolus was never designed for a controlled re-entry, so the satellite would naturally fall back to Earth. But ESA is going above and beyond by attempting an assisted re-entry, the first of its kind. At ESA's Mission Control Center in Germany, teams have saved enough fuel to steer Aeolus during its return to Earth. Predictions on when it will re-enter become more accurate with each passing day, a lot of which depends on solar activity. Solar flares and coronal mass ejections are speeding things up. Charged particles in space weather heat up Earth's atmosphere, causing denser air below to rise, increasing the drag of the atmosphere on Aeolus. While solar activity is hard to predict, ESA is targeting the re-entry for end of July or early August if all maneuvers are successful. Most of the satellite will burn up when it reaches an altitude of around 80 kilometers. However, several pieces of debris may reach Earth's surface. Many months of expertise have gone into planning the optimal location for re-entry, which minimizes the extremely remote possibility that falling debris poses a risk to life. Flight control team is aiming at a stretch of ocean beneath the satellite's track, a long stretch of open water as far away from land as possible. Once Aeolus reaches an altitude of 280 kilometers, an initial maneuver will begin to guide the spacecraft towards the optimal position for re-entry. 4 maneuvers will then usher it down further before hours of critical final checks. Then, a final maneuver will direct Aeolus's journey home. The satellite will return in a matter of hours, the vast majority of it burning up in Earth's atmosphere. Today, satellite missions are designed according to regulations that require them to either burn up entirely or undergo a controlled re-entry at the end of their lives in orbit. This first attempt at an assisted re-entry sets a new precedent for re-entering active satellites that didn't fall under these regulations when designed. With Aeolus, ESA is paving the way for safe re-entries and responsible space. Given the rapidly increasing amount of space traffic, protecting our precious but ever-crowded orbits has never been more important. For more information on Aeolus's re-entry, visit www.esa.int/Aeolus. Thank you for watching.